Welcome to Matrices Academy. This is a playlist on matrices. We are going to see almost all topics related to matrices in this playlist. We are going to see the definitions and some of the types of matrices in this particular video. Okay. Let us go into the definition of a matrix. What is a matrix? A matrix is a rectangular array of m into n numbers arranged into m rows and n columns. Right. Suppose if you see, this is an example of a matrix. So this is an array, two-dimensional array. Right. So some numbers are arranged into rows and columns. Right. So how many rows we have? 1, 2, 3. 3 rows and 4 columns. So this is an example of a matrix. And these numbers we have written inside these brackets are called elements or entries. Right? You can call them entries also. And the order of the matrix. So how do you define the order of a matrix? Order of the matrix is number of rows into number of columns. So how many number of rows? 3. How many number of columns? 4. So 3 into 4 is the order of this particular matrix. Notation, in general, we denote a matrix A to be Aij m by n. Aij m by n. That is, we denote matrices by using uppercase letters only. Right? So we write A, B, C and so on, uppercase letters. And inside this matrix, these entries are denoted by Aij m by n. So here Ij can take, I takes values from 1 to m, J takes values from 1 to n, like A11, A22 and so on. So you can expand this. There are m rows. So A11, A12 and so on, A1n, because the n columns are there. A21, A22 and so on, A2n and so on, AN1, M1. M rows are there, sir. So last row must be mth row. AM2 and so on, AMN. AMN. So this is general form of a matrix of order m by n. And what is the coming to the types of matrices? The first one is a zero matrix or a null matrix. So when do you say a matrix is a zero matrix or a null matrix? If all its entries are zeros. Right. If all its entries are zeros, it is called a zero matrix or a null matrix. So this is a 2 by 2 null matrix. This is a 2 rows, 4 columns. So 2 by 4 null matrix. This is a 4 rows and 3 columns. 4 by 3 zero matrix. And when do you say two matrices are equal? So equality of matrices. Suppose you take two matrices A equal to Aij and B equal to Bij. So when do you say these two matrices are equal? A equal to B if and only if these two conditions should be satisfied. Like the order of the matrix A and order of the matrix B must be same. If this is of order m by n, this should be m by n. If this is 2 by 3 matrix, this should be 2 by 3. If this is 3 by 2, this should be, B should be 3 by 2. Right? So both the orders must be same and all the elements, corresponding elements must be equal in value. Right? So Aij equal to Bij. That means A11 equal to B11, A12 equal to B12, like that. Right? So coming to the next types of matrices, a square matrix. So what is a square matrix? A matrix whose order is n into n, n by n, right? That means 2 by 2, 3 by 3. That means number of rows is equal to number of columns. So you have 2 rows, 2 columns, 3 rows, 3 columns. 2 by 2 square matrix, 3 by 3 square matrix. Simply you can call it as a square matrix of order 2, square matrix of order 3. And what is a diagonal matrix? A diagonal matrix is a matrix A equal to Aij with Aij equal to 0. When for all I not equal to j. That means if I equal to j, what happens? I equal to j means A11, A22. You will get elements like A11, A22, A33 and so, because I is equal to j. Right? So diagonal entries are A11, A22, A33 and so on. Right? So I not equal to j means what? Other than the principal diagonal elements. So other than the principal diagonal elements, except these diagonal elements, remaining all the elements are zeros. We call it as a diagonal matrix. So this is a 2 by 2 diagonal matrix. This is a 3 by 3 diagonal matrix. You can also have a 0 on the diagonal also, right? For example, in place of 3, you can write 0, right? So other than the diagonal, all the entries are 0, because at least one entry on the diagonal should be non-zero. So you can have 1 or 2 zeros on the diagonal, but not all of them. If all the entries on the diagonal also 0, principal diagonal also 0, then we call it as a zero matrix, right? Now, a scalar matrix. What is a scalar matrix? Scalar matrix should be, basically, it should be a diagonal matrix, right? It should be a diagonal matrix in which all the diagonal elements are equal, a constant. A equal to k. That means A11 is k, A22 is k, A33 is k, and so on. So for all I. That means all the diagonal entries are same. All the principal diagonal entries are same. 2, 2. Here k is 2. Here 3 by 3 scalar matrix, 5, 5, 5. All the diagonal entries are same. Here k equal to 5. Next, an identity matrix. What is an identity matrix? Identity matrix is a scalar matrix where k equal to 1. Where k equal to 1. That means all the diagonal entries must be equal to 1. 1 in number, right? So 1, 0, 0, 1. 1, 0, 0, 0, 1. Because it should be a scalar matrix and it should be basically a diagonal matrix. Other than the diagonal, principal diagonal, all other entries must be 0 and the diagonal elements must be equal to 1. That is called identity matrix. So this is a 2 by 2 identity matrix. This is a identity matrix of order 3. So we denote this by I2. We denote this by I3. So identity matrix of order n is denoted by In. So coming to a lower triangular matrix. What is a lower triangular matrix? Suppose a matrix A is Aij. Then Aij equal to 0 for I less than j. So this is mathematical definition of lower triangle. But what is the concept? The concept is all the entries above the principal diagonal are zeros. So when all the entries above the principal diagonal, see, this is the principal diagonal, and you can see all the entries above the principal diagonal are zeros. So if all the entries above the principal diagonal are zeros, we call it as a lower triangle. If all the entries below the principal diagonal, see, below the principal diagonal, all the entries are 0. It is called upper triangular matrix. So below the principal diagonal 0 means upper triangular. Above the principal diagonal 0 means we call it the lower triangular. So triangle is there in the, actually this is the triangle. Not this one, this is the triangle. This is the lower triangle matrix. This is upper triangle. Right. And what is a singular matrix? A singular matrix is basically it should be a square matrix because the determinant is defined for only a square matrix. So a singular matrix means it is a square matrix with the determinant equal to 0. And what is a non-singular matrix? It is a matrix with a determinant not equal to 0. Determinant not equal to 0. Singular means equal to 0. Non-singular not equal to. Non-singular not equal to. For example, if you take A equal to 2, 3, 4, 6, the determinant is 2 into 6 minus 4 into 3. See, the determinant is 0. Therefore, A is a singular matrix. If you take this matrix, the determinant is 2 into 0, 0, minus 1 into 3, plus 3. Right? Minus of minus 3. So, total is 3. That means 3 is a non-zero. The determinant is non-zero. Therefore, B is a non-singular matrix. Okay. Then we will see some other topics, important topics in the next class. Thank you. Please like this video, share it with your friends, and subscribe to my channel. Thank you.